Hi all. In this lecture, we are dealing with group frequency concept in IR spectroscopy. An important observation made by early researchers is that many functional groups absorb IR radiation at about the same wave number, regardless of the structure of the rest of the molecule. Hence, characterization of functional groups in substances according to the frequencies and intensities of the peak is feasible, and it helps to propose its structure. Infrared light refers to electromagnetic radiation with wave number ranging from 14,000 to 4 cm inverse, and this region is further subdivided into three regions: near infrared, mid-infrared, and far infrared. Almost all the fundamental vibrations appear in the middle infrared region. For example, the OH, NH, or CH stretching modes appear in the region of 4000 to 2500 cm inverse. Triple bond stretching modes appear in the region of 2500 to 2000 cm inverse. C double bond C, C double bond O, the double bond stretching bands fall in the region of 2000 to 1500 cm inverse. Bands in the near and far IR region are overtones and combination bands. They are weak in intensity and overlapped, making them not as useful as those in mid-IR. However, absorption in this region, in the near and far infrared region, are helpful in exploiting information related to vibrations of molecules containing heavy atoms, molecular skeleton vibrations, etc. As I said earlier, the functional groups show these same regions regardless of the structure of the rest of the molecule. That is, the CO group, whether it is an acid part or aldehyde part, will appear between 1500 and 2000 cm inverse. This make these bands diagnostic markers for the presence of a functional group in a sample. These types of infrared bands are called group frequencies because they tell us about the presence or absence of specific functional groups in a sample. Thus, the main application of IR spectrum is the compound identification. So, if we have an unknown compound whose functional groups we wish to identify, we can examine its IR spectrum and use this data to deduce which are the functional groups present. Here is given a list of the characteristics absorption frequencies of some prominent functional groups. So, if we are having group frequency concept, approximate frequency of many functional groups can be identified. Here you can see a fingerprint region below 1500 cm inverse. What is this fingerprint region? The region of infrared spectrum exactly from 1200 to 700 cm inverse is called the fingerprint region. This region is notable for large number of infrared bands that are found there. Many different vibrations including CO, CC and CN single bond stretches, CH bending vibrations, and some bands due to benzene rings are found in this region. This pattern of vibrations is uniquely characteristic of each molecule and hence give rise to a uniquely characteristic set of absorption band in the spectrum. The utility of the fingerprint region is that the many bands there provide a fingerprint of the molecule. Now, let's take a look at the IR spectrum of 2-hexanone. The main absorption peak in this spectrum is from the carbonyl double bond at 1716 cm inverse. The peak at approximately 3000 cm inverse is characteristic of CH bonds. This peak is not much useful as just about every organic molecule that you analyze will have these CH bonds. You may notice the many additional peaks in the longer wavelength region, which is the fingerprint region. It is very difficult to pick out any specific functional groups from this region, but it can provide valuable information. To identify an unknown compound, one need only compare its IR spectrum with a set of standard spectra recorded under identical conditions. So, the infrared spectrum is most useful for providing information about the presence or absence of specific functional groups. It can provide a molecular fingerprint that can be used when comparing samples. In IR spectroscopy, group frequencies are more valuable than single absorption bands. In other words, a functional group that gives rise to many characteristic absorptions can usually be identified more definitely than a functional group that gives rise to only one characteristic absorption. To be more clear, I can explain by an example that esters having C double bond stretching and C single bond stretching are more easily identified than ketones having only a C double bond stretch, and also amides which are having C double bond stretch, NH stretch and NH single bond bending are more easily identified than esters. It is also interesting that absence of a characteristic absorption may be more illuminating than its presence while identifying a molecule. IR spectroscopy having some limitations that it does not provide a detailed information or proof of molecular formula or structure. It provides information on molecular fragments, specifically functional groups. But it is not possible to identify a compound merely by interpreting its IR spectrum. All other evidences like NMR or mass spectral data and other chemical or physical evidences should be assessed to get a complete picture of molecular structure. By this, I conclude my lecture on significance of group frequency concept in IR spectroscopy. Thank you very much.